Okay, so welcome back. So now let's do another example of partial fractions. So now in this example, we have a situation where the numerator on the degree of the numerator is not less than the degree of the denominator. So we're going to have to do long division, okay? So do the long division first. And so we're going to rewrite this. And if you do the long division, you should get this. And again, I'm not going to do the long division for you. You should know how to do that by this class. So if you do the long division, you get 1 plus, and then you get a more simple fraction with the remainder. So in this case, you get 3x plus 5 over the x squared minus 4. Okay, now we can go ahead and decompose this piece right here. Okay, so this will become, oops, do I need my dx? Okay, so this is going to become 1 plus, this is going to become 3x plus 5. And this becomes x plus 2 times x minus 2. Okay, so now we've got it decomposed. Okay, and so now we're going to set up our constants. So now we know that this has to equal 1 plus, and now we're going to rewrite this into two fractions because that has to be a divided by this plus b divided by this because we got distinct linear factors. So now this is going to be a over x plus 2 plus b over x minus 2 dx. And so now we have to figure out what a and b are. Now, let's set up our equations, right? So now, what does this mean? Well, this has to equal what? This, 3x plus 5. So if we do our scratch work, okay, so let's do it this way. So here's our scratch work, right? So that means we know that 3x plus 5 has to equal a times x minus 2 plus b times x plus 2. Okay? That's our equation. And so now, this is where we can use strategic substitution. As long as you make sure that these are set up correctly, you should be able to use strategic substitution to find a and b. So again, if we say let x equal to 2, right? If x equals 2, what happens to our equation? Well, in this, on the left side, we get 6 plus 5, which is 11. And we get 11 equals, well, the a goes away to 0, right? Because this is 0. So we get b equals what? 11 equals b times 4. Which tells us that b equals 11 fourths. Right? So b equals 11 fourths, and so we've got one of the two that we want, that we need. Okay, so now there's one. So now I'm just going to solve for that one. Now I'm going to make x equal to negative 2. And if x is equal to negative 2, I get negative 1 on the left. The b goes away because this is 0, and I get negative 4. So I get negative 4a. And so that tells me that a is equal to 1/4. And so now I'm done, almost. Now I just have to integrate. And now I can easily integrate this because this, I can just integrate term by term. These are both going to give me natural logs, right? Because I've got du over u. So now what do? This is going to become x plus 1/4 the natural log of the absolute value of x plus 2 plus 11/4 times the natural log of the absolute value of x minus 2 plus c. And that's it. See you next time.